All right, ladies and gentlemen, good morning once again. Let's continue. That's the last part of this chapter. We'll talk about logarithms in this video, in this class. So we have already covered that indices, solving exponential equations, and surds. The last section of this chapter is about logarithms. Okay, and as I told you earlier, when you talk, for example, when you are dealing with compound interest problems. Okay, if you remember, when we are dealing with compound interest problems, here we have amounts that's equal to P principal 1 plus rate to the power T, right? For example, here, if you just suppose that's your principal, you invested $5,000, okay? And the bank offers the compound interest rate as, let's say, 3.2% per annum or per year, okay? And also imagine that you want your money to grow. For example, let's say you need $6,400, all right? So for this money, $5,000 to grow to $6,400, and at this rate, how much time is needed or how many years, right? To answer this question here, the problem is we need to find T. So if you substitute here to find this T, if you want to make this T the subject of the formula, how do you do that? First, I should divide both sides by P, right? So here we have P, or 1 plus R to the power T, that is equal to A over P, right? Now the question, how can I actually leave this T alone on the left-hand side and take everything that is in capital A, capital P, and this R, keep them on the right-hand side, okay? Using all the operations of knowledge that we have learned earlier, actually, they don't help because we cannot do this by just doing some elementary operations, adding something or multiplying something, dividing by something, whatever it is, we cannot do this. So actually, such problems, similar problems, force mathematicians to introduce something new concepts, okay? What I have here, if I just denote this with for example, let's say, A, and this T by, let's say, this X on the right hand side, here we have something, let's say this B, okay? I just denoted with 1 plus R with A, and this T with X, here A, capital A over capital B, that's B. The question is, how can I express this X in terms of A and B? Okay, that's the problem. So that is not possible. That's why actually we are forced here to introduce something new terminology or new notation, okay? And we are going to call this logarithm, all right? So if a number y is expressed as the exponent x of another number, like y is equal to, here we have y is equal to a to the power x. Here we have some exception, a must be positive and a should not be equal to 1, okay? And why we are also adding these conditions, because if, for example, let's say a equals 1 to the power anything is equal to 1. There is nothing to learn here, or there's no any challenge here, right? And the second reason why a should be positive. Let's say a is negative. Can it be negative, like -2? If we just write here -2 to the power x. And also here, y, let's say we have one example, y equals -2 to the power x. Okay, and what kind of problem we face here? The problem is, here we have -2, and this x is anything, and we do not define such power. All right, when we're defining power function, this base must be positive. And we cannot study the behavior of this function, number one. Number two, we do not face such problems that actually leads to this kind of equation in real life. Okay, at least now we don't have such thing. That's why we are not considering this case when base is negative. So here base must be positive and also should be different from 1. If it is so, then we are introducing this new notation. If y is equal to a to the power x, then we are defining this. Then x is denoted as log, here we have a y, right? How do you read this? Here we have x is equal to logarithm of y to the base a, because this one is base, right? So that's our function, that's our exponents. So we are expressing exponents, all right, in terms of something. So this is how we define logarithm, okay? Because in many cases, like for example, if we have 2 to the power x equals 4, I can solve this, right? 2 to the power x is equal to 2 squared. Now from here, what's x? X equals 2. Now how about if we have this kind of question, 2 to the power x is equal to 3, for example. How do you solve this? We cannot solve this, but it doesn't mean that it doesn't have solution, right? It has solution, but in the usual ways, we cannot solve this. So now we know that using this notation, what is x? X equals logarithm of 3 to the base 2. Okay. Now using calculator, we can evaluate this, but you may be interested, okay, how calculator calculates this? Okay. It is not in the scope of this course. That's why I don't want to talk about this. To evaluate these logarithmic functions, we need to use integral. All right, using integral, then we can calculate this. All right, that one, we just omit this. That is not in the scope of this course. This is what you have to know here. Okay, how to express things in terms of logarithm and to do some operations using logarithm or solve problems involving logarithmic functions. Okay, examples. So convert the following to logarithmic form. These are exponential forms, so we have to convert them into logarithmic form. The first one, here we have a to the power 3 equals 8, right? Then exponent is 3 here. So here we have a, that's 3 is equal to logarithm of 8 to the base 2. That means that 2 cubed is equal to 8, right? How about b? Here we have negative 2 is equal to logarithm of the value of the function 1 over 9 to the base. What is the base here? 3. 3, right? That means that 3 to the power negative 2 is equal to 1 over 9. So here our exponent is here. C, how about this one? That x is equal to logarithm of 47 to the base 2. That means that 2 to the power x is equal to 47. Another example, convert the following logarithmic forms to exponential form. All right, the first one, a. So here we have logarithm of 32 to the base 2 is equal to 5, right? So that is the same with 2 to the power 5 equals 32. 2 to the power 5 equals 32. Okay. Here we are just practicing about these notations. Okay, you don't have to calculate anything, just you have to get used to convert from exponential form to logarithmic form and logarithmic form to exponential form, because it's very important in solving logarithmic equations. In many logarithmic equations, we have to simplify and convert them into exponential form, then we can solve it. How about b? Here we have logarithm of 9 to the base 3 is equal to 2, right? So these two things are equivalent. That is the same thing as 3 squared, because this is an exponent, right? It's a base. 3 squared is equal to 9. And how about c? Logarithm of 1 over 4 to the base 2 equals x, right? So they are equivalent from here. This is base exponent 2 to the power x is equal to 1 over 4. All right. some other examples, it says find the value of each of the following. How can we do this? So to do this one, we need to convert them into, what is it, exponential form, right? Let's say, what is the value of this one? Let's say that's equal to logarithm of 64 to the base 2. Let's say is equal to x. So we need to find the value of x, right? So if I change this into exponential form, base exponent 2 to the power x, 2 to the power x equals 64, right? Now from here, we know how to solve this. What is x? X equals 6. So the value of this thing is equal to 6. B, logarithm of 4 to the base 1 over 2 is equal to, let's say, y, right? And using the definition, that is the same thing as this base, right? Exponent 1 over 2 to the power y is equal to what we have here. Here we have 4, right? Now from here, 1 over 2 is, we know that 2 to the power negative 1. Negative 1 times y is negative y. On the right hand side, we have 2 squared. So what is y? Y is equal to negative 2, because negative 1 times negative 2 is equal to 2, right? How about C? C, logarithm of 1 to the base 3 is equal to, let's say, t, right? So if we just change this into exponential form, 3 to the power t is equal to 1. And what is 1? I can write 1 as 3 to the power 0, because 3 to the power 0 equals 1. 3 to the power t equals 3 to the power 0. So from here, t is equal to 0. But you will see that actually if here we have 1 to the base anything is always equal to 0. D, logarithm of 0.25 to the base 8, that's equal to, let's say, k. So we have to find k. From here, 8 to the power k is equal to 0.25, right? And 1 over 8 is 2 cubed, that is 2 to the power 3k. And how about 0.25? That is 1 over 4, right? 25 over 100, that's equal to 1 over 4. That's equal to 2 to the power negative 2, right? And you know how to solve this. From here, what is k? K equals negative 2 over 3. That is the value of the last logarithm. So that is equal to minus 2 over 3. Okay. All right. Now let's practice some logarithmic equations. Solve the following equations. So again, to solve logarithmic equations, first we have to simplify. And after that, we have to convert this into exponential form. And just we have to solve it. And you know how to solve exponential equations, right? From the previous video. So here we have logarithm of x to the base 2, that's equal to negative 1, right? Let me just draw something here. So here we have, if we convert this into exponential form, x is equal to 2 to the power negative 1. That is dot, 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 x is equal to 1 over 2. That is the solution of this logarithmic equation. How about question B? Here in a similar way, here we have logarithm of 81 to the base x plus 1 equals 2. So if we convert this into exponential form, here we will have 81 is equal to, this is the base x plus 1 squared, right? Now from here, what is x plus 1? X plus 1 squared is equal to 9 squared, right? Actually, it's plus minus, right? So that is, if you just solve this by factorization, take to the left-hand side. Here we have x plus 1 plus 9 and x plus 1 minus 9 is equal to 0. From here, x equals negative 10. From here, x equals 8, right? And the base, we know that the base should be here, this thing that's equal to A, right? That should be positive. Otherwise, it's not defined. So when x equals -10, -10 plus 1, it is -9, so it is negative. So this answer is rejected. So when you're solving, you should be careful because in the definition, we say that the base is always positive, right? And here, when it's 8, it is 9, is correct. 9 squared equals 81 is correct. Dot, dot, dot. The solution of this equation is 8. And the last one, C. Okay. Again, here we know that x is positive at the beginning because in the base, we have to just keep it in mind. So if I convert this into exponential form, what we have here? Here we have x squared, right? X squared equals 5x minus 6. Take everything to the left-hand side. Here we have x squared minus 5x plus 6 is equal to 0. It's just a quadratic equation. And if you solve this by factorization, -2 times -3, it is 6. -2 plus -3, it is -5. So I can factorize it as x minus 2 times x minus 3, which is equal to 0. So x equals 2 or x equals 3, right? So when it is 2, 10 minus 6, here we have 2 positive. When x equals 3, also it works here, no problem, right? So dots, 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 values of x are, what is it? X equals 2 or x equals 3. That is the solution of this, the given logarithmic equation. Okay. Laws of logarithms. So we have some rules, some properties of logarithms. Okay, these are the most important ones, and using this one we can actually generate other laws. So the first one says that logarithm of m times n to the base a is the same as the sum of logarithm of m to the base a plus logarithm of n to the base a. Okay, if it is division, here we have minus. If we have here power, it just counts to the front. Why is this so? Let me just prove only one of them here. The first one, let's say that is our first property or rule. Second one, and this is the third one. Okay. And what is the proof of the first one? Why actually it is equal? And using this idea, also you can just see this. All right. Here it's saying that logarithm of m times n to the base a, right? So is equal to this. I assume that, let's say this thing is equal to x. This thing is equal to y. Okay. What we have here? Logarithm of m to the base a is equal to x. And logarithm of n to the base a, let's say, is equal to y. Using the definition, what is it? Is equal to m equals a to the power x. How about this thing? That's equal to n equals a to the power y, right? Now, if I multiply both sides, what happens here? Here we have m times n. What is m? m equals a to the power x, n equals a to the power y, right? And using the exponents, here we can write it as a to the power x plus y. Now using again the definition of logarithm, here we have something equals something to the power of this, right? So what is x plus y? X plus y is equal to logarithm of, right? Here we have mn to the base a. Okay. Now what is x? X equals this. What is y? Y equals this. Equals on the right hand side we have logarithm of mn to the base a. Okay. So in a similar way, also we can prove this. If I just divide these two things together, for example, what happened here? If I divide them For example, m over n. That is the proof of the second thing. What is m over n? Here we have a to the power x over a to the power y, which is equal to a to the power x minus y. Now using the definition, what is x minus y? That's equal to logarithm of, here we have m over n. So here we have m over n. And to the base a, to the base a. So this logarithm of m over n to the base a equals x minus y. What is x? X equals logarithm of m to the base a. And how about this y? Logarithm of n to the base a. So here we have minus. Okay. And also this thing, by using this logarithmic things, I can actually prove that. Okay. Because this one, k times logarithm of m to the base a. Right. What is this? Actually, that is equal to, right? This one, this thing is equal to, here we have logarithm of m to the base a plus logarithm of m to the base a dot dot dot. Here we have logarithm of m to the base a. If I assume that k is here positive integer, right? And how many such terms we have? Here we have k such terms, right? And using this one, if we have logarithm of m to the base a plus logarithm of n to the base a, what does it just mean to multiply this, right? So this thing is equal to logarithm of a. Here we have m times m times m times m. How many m? K. So that's equal to m to the power k, right? On the left hand side we have this. On the right hand side we have this. So these are the proofs of these properties. All right. One example, simplify the following. Question A. So if you notice here, bases are the same, and here it is added. So that's equal to logarithm of 4 times 5 to the base 2, which is equal to logarithm of 20 to the base 2. Simplified. The second thing, B. So using the third property, I can bring this here, right? I can write it as logarithm of, here we have a 5 squared minus logarithm of, in the base here we have 2 cubed, right? Here we have bases the same, here we have division, right? And using the second property, I can write it as logarithm of 5 squared. 25 is divided by 2 cubed, that is 8 to the base a, right? That's all. Here we have 25 over 8, logarithm of 25 over 8 to the base a. Simplified. Some other examples. A, example 15. So logarithm of square root of 2, the base is 4, right? Here we have base 4, good. And here it is added. So I can write it as logarithm of square root of 2 times square root of 8, right? And here the base we have 4, which is equal to logarithm of square root of 2 times square root of 8, that is 16, right? Square root of 16 is 4, so here we have 4. And 4 to the power, what number equals 4? That's equal to 1. All right. B, here we have 2 bases, all bases are 2, no problem, right? To add or subtract, I need to bring this inside. So the first one is logarithm of, the base is 2, right? 2 comes to the power as a power of this 2 over 3. So here we have 2 over 3 squared. Plus, the second thing we have no problem, logarithm of, in the base you have 281 over 8. Minus, here we have logarithm of, in the base we have 2, 3 over 4, and the squared, which is equal to, all bases are 2, so here I just write logarithm, the base 2. So these are added, right? Here we have 4 over 9. So let me just open bracket here, 4 over 9. Here added, so here we have times 81 over 8. Here it is subtracted, so here we have division, right? And 3 squared over 4 squared, that is 9 over 16, right? So if you simplify this here, if you simplify right here, here we have 4 over 9 times 81 over 8 times, here we have 16 over 9, right? This 81, 9, 9, they cancel each other, right? 16 over 8, it is 2, so this thing is equal to 8. So what we have here? Here we have equals logarithm of 8 to the base 2. 2 to the power, what number equals 8? That is 3. Right? So the value of this logarithm is equal to 3. All right. And the last one, as see here, we have the all bases 10, 10, 10, 10. Only here we have coefficient, right? First, I can just to do this C, I have to write this thing, logarithm. In the base here we have 10, right? Here we have 4 over 35, 4 over 35. And the times, because of this plus, it is times 70. Here we have minus divided by 2. And here added, it is times, right? 2 comes to the power of, as a power of 5. So here we have 25. So we have to simplify this. Equals logarithm of, here we have 10. Here 70, 35, they cancel each other, 2 left here. 4 times 2, 8. 8 is divided by 2, it is 4. 4 times 25, it is 100. So 10 to the power, what number equals 100? That is 2. Right? Because 10 squared is equal to 100. Okay. Yeah, we have 2 examples left, and then I'll finish the class for today. Okay, 16, next example. I like green color for some reason. Solve the equation. Here we are given logarithmic equation, right? On the left hand side, here we have 2 terms here. On the right hand side also we have 1. First we have to simplify them, and after that we can actually, how to say, here we have 10, here we have 10, 10. So I'll try to bring this into this form. Logarithm of, here we have f of x to the base 10 equals logarithm of g of x to the base 10. Everything is the same, right? For these two things to be equal to each other, also this f should be equal to g, right? So actually I will convert this into this. Here we have f of x equals g of x. So these are two things are equivalent. Okay, of course here f and g, we know that they must be positive. So to do this one, here we have 10, 10, right? On the left hand side we have logarithm of it is minus, so here we have 3x plus 2 is divided by 2 comes to the here, right, x squared. Here we have x squared to the base 10. On the right hand side, this 10, 1, I can write it as logarithm of 10 to the base 10, right, because it's equal to 1. So here we have a logarithm of the base, we have 10. So here we have 10 over, because it is minus 5x minus 3. 5x minus 3. Bases are equal, right? So here we have 3x plus 2 over x squared. Okay. X squared is equal to 10 over 5x minus 3. If you cross multiply, what do we get here? Here we have 3x plus 2 times 5x minus 3 is equal to 10, right, times x squared. If you remove the brackets, 3 times 5, it is 15x squared. 3x minus 3 is minus 9 plus 10, so it is plus x minus 6 equals 10x squared. Or simplified further, 5x squared plus x minus 6 is equal to 0. Right? If we solve this by factorization, here we have 5x. X, this one is 1, 6 or 6, 1. Here we have 6, 1. So it is plus, let me put minus here. 5x times x, 5x squared, 6 times negative 1, negative 6x, Cross multiply 6x plus minus 5x, that's equal to x, right? So we can factorize it as, let me just here, we can factorize it as 5x plus 6, x minus 1 is equal to 0. Or x equals minus 6 over 5, or x equals 1, right? But here we know that here it should be positive, right? Because the positive number to the power anything is positive. So this answer is rejected. So x is equal to 1. That is the answer. The solution dot x is equal to 1. Okay, when it's 1, we have no problem. Here it is plus. Here we have 1, right? It is plus. Okay, guys, the last example, solving the system of logarithmic equations. Okay, here we have two equations. They involve logarithms, and that's why they are here. So again, we need to simplify this and convert them into exponential form. The first thing is, here we have x minus 4y is equal to 2 to the power 4. Just using the definition. And here, if I simplify this, this thing is equal to logarithm of divided, right? 4x is divided by 8y plus 5 to the base 8 is equal to 1. So here I can write it as 4x over 8y plus 5 is equal to 8 to the power 1, right? And what we have here? Here we have x minus 4y is equal to 2 to the power of 4, 16. If you cross multiply and take to the left-hand side, here we have 4x, 8 times 8y, 64y, take to the left-hand side, minus 64y. On the right-hand side, 8 times 5, here we have 40. Right? Now, how can we solve this? As you see here, all these numbers are divisible by 4, and after that we can just subtract them. I can eliminate x, we can get the value of y, and substitute here, we can get the value of x. So I can rewrite these equations. X minus 4y is equal to 16. Divide both sides by 4. Here we have x minus 16y is equal to 10, right? So if I subtract the second equation from the first one, minus x, 0. Negative 4 minus 16, that is 12y, and 16 minus 10, that is 6. So from here, what is y? Y equals 1 over 2, right? And substitute here, let's say x minus 4 times, what is y? 1 over 2. 1 over 2. On the right-hand side, we have 16. So that's equal to 2. What is x? X equals 18, right? So dot, the solution of the given system of equations, x equals 18 and y is equal to 1 over 2. All right, guys, that much is enough for today. Okay, and you keep practicing questions. As I told you once again, and I tell you, all the questions for the final come from chapter 8, 9, 10, and 11. Okay, and chapter 11 we will see if I can start. We will do some stuff from chapter 11. Otherwise, I will stop with chapter 10. Okay. Thank you very much. Have a nice day. Okay, enjoy your lunch. See you next week.